Why multiplication is confusing, especially when it comes to multiplying integers and fractions. Multiplying with negative numbers indeed is a major problem. The root cause is our thought process, which tells us that multiplication is only repeated addition. It is a form of repeated addition engraved in our minds, which actually creates this problem. So, in this particular video, we are going to take a few examples and illustrate what truly multiplication can be thought of with an innovative idea developed by Anil Kumar. So, it is being called as a new standard for multiplication. It is actually multiplication transformed. So, we'll see how this transformation helps in understanding multiplication and makes it very simple to move from this repeated addition concept when we say 3 times 4 equals to add 4 3 times. Now, when you talk about minus 3 times minus 4, how to add negative times, right? So that's a very big question to answer. So basic concept with kids is that 3 times 4 basically means add 4 3 times. Now, when I say minus 3 times minus 4, so means what? How many times should I add minus 4? Minus 3 times. How do I add that? And it becomes even more difficult to understand when we say minus half times minus 3 by 4. How can you add a fraction number of times? This in itself is a PhD problem, right? At school level, especially junior middle school, is extremely difficult to understand. And now we see why multiplication is confusing. So it is alarming, and here is how we can address it with absolutely new approach, right? So the whole objective here is to help students understand the concepts, and the teachers and other education providers can also adopt this approach to help them out, right? That's the whole thing, right? So this is the alarming confusion about multiplication which is being addressed by me now. I am Anil Kumar sharing with you a new look at multiplication. Break free and rethink multiplication with these brilliant ideas. So, to begin with, multiplication is understood as repeated addition. Now, when that comes, it is good when you are multiplying two positive numbers, right? And so it's not a problem. But what happens as you know that product of positive and positive numbers is positive, that is clear to us. And as soon as we go to integers, we are taught that product of negative and positive number is negative. So when there are opposite signs which get multiplied, you get a negative answer, but it's not very clear in the minds of our students. Why so? Similarly, when you say product of negative and negative number is positive, right? Okay, so then how it really works, right? So that means we look at this multiplication when we introduce to them as integers. We say, well, if you are multiplying positive and negative numbers, then these are the options for us. And if there are two positive numbers, you get positive, right? I mean, same sign. But if the signs are different, we get negative. In this case, we see that if these this is negative, let me write positive and negative here. Correct. So when you multiply opposite signs, you get negative, but when you apply multiplication on same signs, you get positive. Well, this is well-known fact about multiplication integers, and we get over this topic kind of. We skip the problem of confused multiplication for some more time till you hit the fractions. So now what we are doing here is addressing all of them at one shot, right? So we'll show you that this particular concept of repeated addition doesn't explain these rules well enough. So let's fix them now, correct? So when we are saying 3 times 4 is 4 plus 4 plus 4, or add 4 three times, but then minus 3 times minus 4, how to add negative times. So that's what is a major problem, correct? Great. So now let's break free and rethink multiplication. So here is the new model, the base of the new model developed by Anil Kumar. So we'll see and remove this confusion of multiplication. We'll begin with negative numbers, but in this particular video, we'll talk about fractions also. So this is the model, the multiplication transform model, which is being developed by Anil Kumar, introduces a groundbreaking way to understand multiplication. This video will illustrate how multiplication transformed redefines integer multiplication, making it intuitive, visual, and applicable in real world scenarios. And the same will be extended to fractions. Okay. So it will be then called a universal approach beyond numbers, right? So at the end of this video, you will understand how this particular model addresses, and it is called the universal approach to beyond numbers. When I say beyond numbers, we'll also consider complex numbers and others in our following videos, right? So it really structures transformation model for multiplication at a higher level. I'm going to show you this part of it, right? In this video, we'll restrict ourselves to multiplication with integers and fractions. Great. So here are the major points which we are looking into. Why multiplication is confusing for negative numbers in the first part, then for the fractions in the later half, and we are actually introducing to you the multiplication transformed, a new model address. So the questions are: why does repeated addition fails for negative numbers? How does multiplication act as a scaling transformation? So when we are talking about this new approach of multiplication transform, first point to understand is multiplication really is a scaling factor. So when you multiply things, you scale them up, right? So enlarge them or you make them shorter, right? That is what it is. Second role is the role of multiplication identity. That means when you multiply by 1, it remains 1, right? That means the scaling factor is 1, right? And the negative sign reversal means when you multiply by negative 1, the sign reverses. That is the negative sign reversal. When I apply this strategy in real life application, a car moving in the north direction, when you say negative times, it is supposed to be moving in the south direction. So the direction changes, right? That's a key to it, right? So now I hope you got the idea. Two key features which have been introduced here are that it is a scaling factor and it has that negation capacity in it when you multiply by a negative number, which acts as reversal of sign. If something is thrown up, it will come down, and that is the reversal of sign. Going up treated as positive, going down will be treated as negative, right? So that is the thing, correct? So now we'll take step by step breakdown of the negative multiplication and then address some real life application just as I was talking about. Hmm. So by the end of this video, multiplication will be a whole new way of thinking. Great. So let's help our students to understand better. So here is the first thing to give you an idea of the two things which we talked about. One scaling factor, the other one change in direction, correct? So how does multiplication act as a scaling transformation? That's the first part. Scaling means what happens when I times it two times, right? So here it is. We have some arrow. This is, let's take the example number one. So if I say times two, right? So we are not even taking numbers in this particular case because this approach can be applied to beyond numbers, right? So now here, let's say this is something, and we multiply it two times, it literally means that just double it up in the same direction, correct? So let me make a proper line. So it is going to get like this, correct? And there you go, right? So this is the effect of multiplication. Extend it twice, scale it, correct? For example, the next one here, let's say this is there, and we want to do it times 3, right? Let's do times 3. That means what? That really means this is 1, right? This is 2, correct? And then this is 3, correct? So there you go. So it becomes times 3. Now, soon we are going to, let's say, we give them a magnitude of A, right? So if this is A, then 3A, 3 times A will be this length which we are talking about. You get the whole idea, right? Now, here we have another example. Let's make it shorter. So, if I times it with half, this is multiplication by fractions, means just reduce it to half, correct? So, that becomes times half. You see that? So this is half of what was there. So, if there was B length, B could be any number, right? Could be 10, half of 10 will be 5. Does make sense to you, right? Now, it can be applied to anything, the numbers also. Let's say this represents a number, let's say number is 3, right? So, if I times it by 2, then what happens? That means I'm doubling it in the same direction, correct? And there it goes. So, then this will get extended and that will be represented as 6. You get the whole idea. Now, in this particular case, we actually saw scaling factor and without negative sign purposely so that you get an idea. So, any number, when you multiply, let's say 10 times 5, it really becomes what? Scale it, it becomes 50. And if I do 10 times half, it becomes 5, right? That is the scaling. So, you reduce the numbers. That is what multiplication is, and not just reduce, it is scaled, right? That is multiplication. Great. So now let's also look into the concept of identities, right? When you multiply by 1, what do you get? You get the same number, right? So if I times it with 1, then it remains same as it was. Correct. So that's so simple. So if I say it is 5 times 1, it is 5, correct? However, what happens if I multiply this by minus 1, right? So let's take another one. So if I times this with minus 1, then it happens what? Put it in brackets. So it reverses and the direction changes. Do you see that? So that becomes minus 1. So let's say if it was B, now this is minus times B. That is reversal. Now, when you multiply by a negative number, what is happening? Sign reverses. So if it was, let's say it was 6, right? 6 times minus 1 will give me minus 6. The sign reverses. So two things. In the first part, we saw how scaling works, right? It gets enlarged or it gets reduced. Now, in this particular case, what you're noticing is that if I multiply with 1, the magnitude and both direction remains same, right? So times 1 means the same thing, right? So it is C. So C is C, right? C times 1 is C. You get the whole idea. C is C. But on the other case, let's say we have D, but if we times it with minus 1, it becomes what? It becomes minus D. Both. Sign changes, right? That's the magnitude remains same. Scaling factor is 1, correct? Sign changes. Now, that is what the beauty of our transformation is. So, the transformation, in true sense, when we talk to you in terms of numbers, mainly becomes that the numbers get multiplied, means scaled. So, what we learned in these two parts is one, multiplication is the scaling factor. If I multiply a number by something, it gets scaled by that factor. Second, if we multiply by a negative sign, the direction changes. So, this is a combination of the two. So, I hope this concept is absolutely clear, right? So, that is what we are saying innovative and an extremely creative approach to look at this particular important topic, which is the foundation, correct? Now, let's also take up another example where We are going to place things on the coordinate plane just to show you how this innovative approach actually applies to all real life situations, right? So what we have done for simplicity is taken a line segment along x-axis, right, of 3 units. Now, if I do, let's say, if I call this from O to A, let us say, right? So O to A is what we are seeing as 3. So I'm saying OA in geometry, it will be like this, is 3, magnitude, magnitude. But if I multiply it with, let's say, a negative 1, let's say negative 1, so what happens? So if I say this OA is now times with negative 1, then be negative 3. Means it will be shown as this on your graph. Get the whole idea, right? So it's a reversal. If it is on the x-axis, it becomes along the minus x-axis. And if I take the other example, which is right here, shown as the other segment, let's say this is point B, right? So here we are saying OB is 2. Since it is going upwards, we are treating this as positive 2. But as soon as I multiply this OB by, let's say, 2, right? So if I did 2 times OB, it becomes 2 times scaling factor of 4. So it will become 4. Do you see that idea? So the direction is not changing, it is just getting multiplied. And there you see it becomes scaled and large, as seen here along the y axis, becomes 4. So with that, you see that any particular geometrical figure can be scaled, right? So if we can scale along x and y axis, we can scale anything on the coordinate plane, may it be something like this. Correct? So if I multiply this by a negative number, it is just going to go like this. You see that? This is multiplication by negative, let's say 2. Correct. So we have now covered with this concept a wide variety of examples which illustrate that the transformed multiplication which we are talking about is about two things. One, scaling factor, and the other thing is negation. Multiplying by a negative number is negation, right? So when we are talking about directed numbers, which are called the sign numbers, makes sense, right? So multiplication is two combinations, scale plus negation, which is reversal of direction. Great. So let's illustrate with the help of examples now, and let's take up the case of minus 3 times minus 4. So I'm going to multiply minus 3 with minus 4 and show you in steps how does it really work, right? So let's say we understand what is 3 times 4, right? 3 times 4 basically means scale, right? So this is scaling. So just multiply the numbers, we get 12. No problems, correct? So this was known, well understood. You can even adopt your strategy of repeated addition to get to this result of 12. No problems. Now, second step, we're just going to change it a bit. We say, what is 3 times? Minus 4. Now, since we have introduced this number minus, minus means opposite sign or negation. Now, negation is a popular term being used in multiplication by negative sign, and therefore I'm keeping it same, negation. So it really changes 12 to minus 12. The only change here is multiplication by minus 1, if you see that, correct? It only means that. So I hope this step is absolutely clear. And now the final step for us is to multiply with negative 3, right? So we negate 3 now, this time. One by one we are doing it. And therefore, this result will again be reversed and that. So two negations is one positive, you can see for yourself. So when you multiply two negative numbers, you do get a positive number, and therefore, what we talked about initially about multiplication, that is absolutely clear, right? Makes sense. So if the two signs are same, we get positive, but they're different, we get negative. And here you can see what is happening. Once you multiply by a negative sign, the sign reverses. Again, it reverses. That means it is same as the original. Perfect. So that I hope clears, and this is what is our model, right? Structures transformation model for multiplication. Great. So that's the creative, innovative approach. So, so I think these steps are absolutely clear. So once again, let us summarize these steps. So when we said minus 3 times minus 4, step by step breakdown is right there before one. The very first step is just multiply the two numbers, disregard the signs. So that is known to you, it is a scaling factor. In this case, it gives you a result of 12. Now, as soon as you reverse one of these signs, it is your choice. Any number you could reverse. So when you reverse minus 4, then the sign reverses, you get minus 12. That's the negation process. And step 3, what we are doing is to the previous one, we negated the other number sign. And therefore, we negate the result, which now becomes plus 12. And mind it, this is model can be extended, right? So we could multiply not only that, you can extend this to any number of numbers, correct? You can multiply with, if you want, minus 5 and continue this process, not just with all negative numbers, you could do any positive number also, for example. You get the whole idea. But these are the steps to be followed one by one when you multiply by negative numbers. In that case, the sign keeps reversing and you get your result. I hope this concept is scalable and clear, correct? Great. Now let's move on to the idea of multiplication with fractions. So the I hope by now you are absolutely clear that repeated addition doesn't make sense at all when we are talking about fractions, right? Now, scaling factor makes a huge difference in our understandings, right? So when we say half, this is one third, 1/3 times 6, right? So let's do this. The effective idea is to really multiply minus 1 over 3 with minus 6. That is what we are going to do. So as I have shown you step by step, it's always good to move in small steps, incremental steps of learning. So here we'll first multiply 1/3 times 6. You can see it is like 1/3 of 6. That is how it really translates to our language. And mathematics is the language, right? So 1/3 of 6 is basically 2. Scaling factor by 1/3 means divide by 3. And you get 2 as a result. Now, the next step, what do? We did minus, means negation, reversal of our previous result, which gives us minus 2. This is reversal of sign. In short, we call it negation. It can be done every time you multiply by a negative number. Next time we multiplied by negative 6, we reversed it further because 6 was being reversed, right? It's as good as multiplying by negative 1 each time. So this gives you plus 2. Makes sense? So that is how we can easily treat multiplication with integers. You see how this innovative and creative approach helps to understand and move forward, correct? You could have multiple examples here. Now, let's take up some real life situations. But I think you have the clear idea of what this approach is and how it can be applied. Now, here is real world applications of integer multiplication. Multiplication isn't just numbers on paper, it models real world scenarios. Temperature drops. A decrease of 3 degrees per hour for 4 hours, correct? So that's a multiplication. Decrease of 3 degrees per hour for 4 hours. So the decrease is given to you by a negative number, which is negative 3. So decrease of in degrees, decrease of 3 degrees, and for 4 hours is the time. So in total, how much the temperature is going to go down? It's going to go down by 12. So chill. So minus 12. You get the whole idea. So you can say decrease is like minus 1, correct? Times 3. 3 per hour. Makes sense. So this negative, which you are multiplying with 3 and 4, so scale factor of 4 on 3 or 3 on 4, both are commutative. Negation because of decrease gives you negative 12 units degrees Celsius. Correct? Another very popular example is profit and loss. A company loses $50 per day for 5 days, right? So minus 50 is being multiplied by 5 to show a loss of $250 in these 5 days, right? So basically, again, we have decrease, right, which is reversal of sign instead of making profit the main purpose. It is not decreasing, and the rate is $50 and it is for 5 days. So 250 is a scaling factor. Negation will give you the value in dollars, right? Normally, we'll write dollars first, correct? So we'll write like this, correct? So we can put negative here like this and dollars. Okay, making some changes. Perfect. Understanding multiplication beyond repeated addition makes real world applications much clearer, as you can see directly from here. Perfect. So I hope this concept is absolutely clear. And that gives you an excitement, the aha moment, right? So, multiplication we have seen conceptualized as scaling quantity and direction reversal, right? So two things we are looking at. We are looking at the scaling of quantities and then directions. So that is the concept unlocked in this particular video. Multiplication is more than just repeated addition. It is a structured way of scaling transformation, right? So call for an action. You can like and subscribe to my videos, put up some ideas and thoughts, right? And that'd be great. So, once again, let us summarize our learnings and understand what we have done here. We have introduced to you a great model for multiplication, which is multiplication transformed. Multiplication scales numbers, it expands, shrinks, or flips them, right? So these are popular, simple words to use. It expands, right? Scaling. Shrinking is also in scaling, right? Or flips, that is a change in direction or negation. Does this change how you see multiplication? Drop your thoughts in the comments and share this perspective with others. Stay tuned for more insights on redefining fundamental math concepts. Next, multiplication of signed fractions. Great. So I hope you understand and appreciate it. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.